Which was the first robot that you built in your life?
Funnily enough, the first robot I built in my life, I realized, oh my God, this is so cool.
Saksham Khurana is an engineer with a lot of passion in robotics and space. His journey spans from designing advanced embedded systems to spearheading NASA's Lunar Rover projects. Where is the world right now in solving those problems when it comes to space robotics?
You could so far only, let's say, transport 50 kilograms at a time to space. Now with Starship, you can transport 2,000 kilograms to space. What is the worst that can happen? There are a lot of unknown unknowns. You had to make sure everything was damn perfect.
What is the life cycle? How can one sort of see how that path looks like?
NASA has really good resources on their website. Their systems engineering handbook is the Bible for any such process. And I think the world would be a much better place if everyone was following it. So what keeps you going is you have to be a little sadist.
Imagine building robots for exploring the moon or unlocking humanity's next frontier in space exploration. Welcome to Build With Shreya, where stories and ideas inspire you to build something extraordinary. And today, we have with us Saksham Khurana, culminating into his current role as the co-founder of Element Robotics, a company that designs autonomous robotic systems that contribute to advancements in space exploration and as well as developing innovative applications on Earth. So, without further ado, let us welcome Saksham to Build With Shreya. So, when I started exploring robotics, it seemed like a very complex field to, get success in.
Yep.
So, how did you sort of start on this journey and into getting so much interest in this field? What motivated you to keep going despite the challenges that, the technology that's involved in the field itself poses for everyone around us?
I think my first tryst with robotics was in BITS Pilani, where I did my undergrad. There I was creating a small hardware for, mapping the entire area around it for up to 6 feet or something. That led me to understand that, hardware is hard, primarily because when software meets the physical realm, that's when things become unpredictable. Because software, if you say A equals 2, it will always be A equals 2.
Mm-hmm.
But then in hardware, when you say go at 2 meters per second, it'll either be 1.5 meters per second or it'll be 2.5 meters per second and vary in between. Because I relate that back to science in class 12 when we used to study physics. And we used to say, all right, assume friction is 0, right? Remember that? That's what happens because the physical world and the digital world, when they collide, that's where the unpredictability comes into play. So what keeps you going is you have to be a little sadist and love to solve problems, right? And then when you have that innate desire to solve problems, that's when hardware becomes so much more fun. And for me personally, motivation is I really love when I can hold things in my hands, right? So software, I can make a website and it works. But I cannot really hold it. It's not a tangible thing.
Yeah.
It's not a tangible thing. Whereas when electronics comes into play or hardware comes into play, robotics comes into play, it's something you can hold in your hands. And that gives you a lot of dopamine rush. So we've had periods where we were down for about a week or so because nothing was working. And the day it worked, I was on a high for 48 hours. So that's the rush that we chase. And that's how we keep going, basically.
Which was the first robot that you built in your life?
So, funnily enough, the first robot I built in my life was MoonRanger, which was at Carnegie Mellon. Before that, I hadn't built Rover. I had built parts of things. I had made PCBs for automotive, etc. But I never actually built a robot. When I got to Carnegie Mellon, and I stumbled upon this course called Space Robotics. It was cool enough to join. And then when I landed in that course, I realized, oh my God, this is so cool. There, I led the whole avionics team and built the entire thing from a paper design all the way through to a functioning rover, which is right now sitting in a clean room in Carnegie Mellon awaiting a lander to fly to the moon.
So talking to the moon, quite literally.
Quite literally.
So, okay, robotics is one part of it,
Hmm.
but space, like, robotics in space, what got you to start working on that aspect? The same course or?
Same course. It was, so I hadn't done robotics per se before that course in my life, and I hadn't done any space before that in my life. I was a space enthusiast, as we all were as when we were kids. Like, I used to read a lot about space. I have bookshelves filled with books about space. But being in India, there was not a lot of scope that I saw. I mean, ISRO obviously has done a fantastic job in putting things into space, but it's not as accessible as I would like to be. Right? People in America, they dream about joining NASA. There's not a lot of that enthusiasm in India, as at least not in my circle when I was growing up. So the first tryst with space and the first tryst with robotics was in the US, where this professor of mine, he had a contract to build and deliver an autonomous rover for South Pole of the Moon to NASA. And I joined that team and ended up leading that team all the way from preliminary design review, where it was a paper design, through to actual delivery of the flight or article.
So to a lot of firsts,
Yeah.
to leading that entire mission,
Yeah.
that was set there.
Yeah.
That would take some entrepreneurship skills that were innate to you. So tell us where that started, because you cannot lead without that.
So yes, you cannot lead without that. The advantage I had was I had been working in India, running my own software company for about 7 odd years before deciding, all right, I'm done with software. I'm bored. I don't have any more challenges to solve here. And that's when I decided to go to the US for my master's. That's where I stumbled upon this. The good thing was my professor, Red Whitaker. He's a robotics stalwart in the US. So he instilled a lot of faith in me. He's like, this is what needs to be done. I think you can do it. And I'm here if you cannot. And for me, it was more of all right, I have led a company. This is not supposedly very different. So I was like, what's the worst that can happen? That was my mindset. Like, what is the worst that can happen? The short answer was, there's nothing bad that will happen, right? Because you're building something and there's no human lives at stake for some reason. And so that's when I decided to take the plunge. I'm like, all right, I can lead the team if you,
And how was it different, leading a company in India versus leading a team that is a project team within Carnegie Mellon? How was that different?
So there were a couple of key differences. One was leading a company, you always have a commercial mindset, right? So how do you make sure that the thing gets delivered and you get the revenue in? That's what leading a company primarily boils down to. Whereas leading a team in Carnegie Mellon, this was more about how do you take something which is completely unknown, like nobody knows how to do it, right? It's a research thing, right? There are a lot of unknown unknowns. By the way, this is one of my favorite words that I learned there. And how do you take those unknown unknowns, have a good enough solution to them, and then actually deliver it? Because as a researcher mindset goes, as far as the researcher mindset goes, all they care about is perfecting their art, right? But as far as the commercial mindset goes, they don't care about the art, they care about the money. So then this was two things merged into one project, had to be married together. And somehow I found myself in a perfect position to balance the two, where I was able to see what the research said, see what the senior people in the project team said, and take that and take my experience from leading the company and see what would be a good enough way to traverse and deliver the whole rover. So that's how my experience with the company actually led me to understand how do you lead the Carnegie Mellon research team, but also to contribute in a way so that you can marry the project delivery with research.
So, I mean, since you were researching so heavily on space applications, right? So, what are some of the key things that you sort of observed as problems that can be solved? Where is the world right now in solving those problems when it comes to space robotics, and what are what are some core opportunities that you see ahead for the world?
So back when we started, this was 2022, right? SpaceX was sending out reusable rockets, Falcon 9 and Dragon and all. Since then, Starship, their flagship rocket that is reusable and capable of interplanetary travel, that has sort of come online, so to speak. Like, it has done a lot of tests and it has proven that it can do certain things. Now, why that is important is it increases the load carrying capacity. Correct. Prior to SpaceX working, that cost was about $1 million per kilogram. Now, with SpaceX into play, right now they have a monopoly, but the expected costs are set to go down to about $20,000 per kilogram. That's a order of magnitude different, right? Now, what that enables you to do, think of it in terms of local supply chain. If you have just a bullock cart, you can only transport so much material across cities, correct? And so the cost of that material reaching from let's say the farmlands to the cities, or from the farm to the factory, or from the raw material extraction area to the factories, that's really high. But the moment trailers with containers come into play, you have everything standardized, you have everything moving fast, the cost of transport goes down considerably. The moment that happens, you have a huge influx of goods that are being manufactured, things that are being done. You have the economy and settlement happening widespread, not just at the place of the resource. So then now take this example and translate it to space. How does that work? You could so far only, let's say, transport 50 kilograms at a time to space. Now with Starship, you can transport 2,000 kilograms to space, right? So when you were transporting 50 kilograms to space at $1 million per kilogram, you had to make sure everything was damn perfect because you did not have an option to fail. Whereas if you can transport 20,000 kilograms at a time at $20,000 a kg, it's a whole different ballgame now, right? You can have university students saying, all right, we want to send a satellite, let's go. You can have researchers saying, all right, this somewhat looks like it'll work, let's throw and see what happens, right?
Yeah.
So the cost of developing things for space, the cost of proving things in space, that goes down. And the moment that goes down, as you see on Earth, the economy flourishes beyond the point of resources, origin of resources. It's the same thing. Your resources are are on Earth right now. Now the economy can flourish beyond Earth. So that is one of the key things that is happening. Another key that is development that is happening in space right now. People are concentrating on in situ resource utilization. What does that mean? In situ is you have resources that are extracted from space and utilized in space, right? So you don't need to be carrying cement and concrete from Earth. You land on the moon, you mine the moon, you build bricks from it, and you build habitats from those bricks, correct? So then you have humanity starting to colonize the moon. That's a word people use, but I would say you are settling the moon, you're settling Mars. The possibilities now become endless, primarily because your cost of transport has diminished significantly. So that's where I see these two things playing a key role in bringing everyone into the space ecosystem. So far, it's just been government agencies.
Right. And what is your perspective on having life outside of Earth? And I'm sure you must be curious and you must have read a lot of things if you could share with our audience.
I think it is definitely fascinating to go to space. However, our generations so far, and I'm talking about thousands of years ever since humans started evolving, we have been on Earth for so long that it is really hard to imagine how it would be like living on another planet, because let's be honest, Earth is conducive for humanity. Everything out there is completely non-conducive, right? Because Moon has no atmosphere, it has very little gravity. Because it has no atmosphere and no magnetic field, every element from space is bombarding that surface. Now, what that essentially means is humans, when they go to the moon, go to Mars, everything out there is going to kill them. Now, in such a hostile environment, living becomes very difficult, right? Imagine finding yourself in the middle of a desert, right? Unless you have the right equipment, everything there is going to kill you. So that's the flip side. That's the dark side of it. The bright side of it is, because you can go there, now you're free to explore a lot more things. Now you're free to bring back a lot more things to enrich the life here, right? And so on the bright side, you have an insurance policy, right? You have a way that you can go to Mars, and maybe in the next 100 years you can make it habitable through chemical processes that you can invoke. So there's obviously, again, very diplomatically, there's pluses and minuses, there's pros and cons. Would I want to live on the moon? Absolutely yes. Would I want to settle there? Not so much, because I don't want to step out every time wearing a helmet, and I don't like riding a bike with a helmet. So imagine, I would not even how difficult it would be to live in an environment which is not for you. So that would be my take on living on the moon.
And if you have some comments on NASA's Artemis mission, and and how like BITS Pilani and CMU sort of contributed to your journey so far.
NASA has this grand vision where the idea is to send people back to the moon. So last time astronauts went to the moon was about, I think, 1972 or something. And then we are in 2025 right now. There has been no moon landing, right? So their grand vision is return humans back to the moon, make a permanent habitat on the moon. So since the last 60 years, we have had a permanent presence in the Earth's orbit through International Space Station, right? So now it's basically taking that International Space Station, moving further away, and going to the moon. That's the idea of the Artemis mission. And it lays the path to go to Mars. Why Mars? We have a whole different discussion why Mars. But the idea is Moon becomes a way station for settlement, and Moon becomes a way station for further deep space exploration. So that's Artemis mission on the technical side. On the programmatic side, Artemis is bringing together space agencies from across the world. So it's not just NASA that's doing this; it's space agencies across the world. Australian Space Agency is a Artemis Accords signatory. Indian Space Agency is an Artemis Accords signatory. So Australia's contribution, the part that we are also a part of, their contribution is to develop an autonomous mining demonstration, right? Okay. Saying that, yes, we can go to the moon, we can autonomously explore and mine the moon and bring it back to a central construction site. So that's the Australian Space Agency's contribution to the Artemis Accords. I'm not very familiar with what's the Indian Space Agency's contribution to the Artemis Accords, but I know India signed the Artemis Accords, I think it was 2023 or 2024, one of those years. India signed the Artemis Accords, and most likely will be contributing to the cis-lunar economy, which is basically transit between Earth and the moon. So yeah, the NASA Artemis Accords, they're bringing everyone together. What was the second question?
So more about the contribution of BITS Pilani and CMU in your journey so far.
BITS Pilani made me an engineer. It humbled me because when everyone who reached BITS Pilani, my cohort, we were all creme de la creme of in our schools and local regions, right? But then when you reach there, it's like everyone is the same, right? Suddenly you go from being the top to everyone is on the top, so you're just average, right? Your average increases, and that's what BITS Pilani introduced for the first time in my life. How do you level up, right? So leveling up was one of the key things, and then BITS Pilani also developed this approach of problem solving because you study everything. I studied thermodynamics, I studied computer programming, and I studied biology. So when you're given such diverse, subjects, and you have to consume them, perform in the exams, understand them, you sort of start developing a common learning framework for yourself, right? How do you take something which is completely unknown to you, understand it, and deliver on it? That's the approach that BITS Pilani built. And CMU, of course, again leveled up, where it was not just India now, it was across the world. So you have people from China, you have people from Russia, you have people from Kazakhstan, you have people from Israel, you have people from the US. Everyone from across the world lands in that melting pot of diversity, and everyone has done phenomenal stuff back home. And so when you go there, you're further humbled. You're like, all right, I thought I was doing something with my life, but guess what? There's so much more to be done. Again, a humbling experience, but at the same time, very empowering experience. Because CMU, and especially working on MoonRanger and all projects, that told me I don't need to be the subject matter expert to actually deliver on something. That was the biggest takeaway for me from CMU. And when you learn that, the incredible amount of confidence that it builds in you, that it instills in you, that starts showing up in other aspects of your life. And so that was the key contribution from CMU. And of course, I got to work on a NASA project as an immigrant, whereas NASA does not let immigrants usually work on space projects. So that was something phenomenal that happened. It was like once in a lifetime chance for me.
So I'm curious, like as a software engineer, the turnaround time to when you can feel gratified is very short.
Yep.
You can just sit on your laptop, build something up, and within 2 months, you're out in the markets, live on App Store, you get 1 million downloads and you're happy.
Yep.
I mean, of course, that's a bright story. It doesn't happen that way, but it can happen.
It can happen.
It's a possibility.
Yeah.
But with robotics, and that too in space, which is a highly regulated area, what is the kind of timeline you're looking at and how do you keep going?
So let me set some timeline context for you.
Yeah.
When software related things are planned, we plan 3 months, 6 months, 1 year, right? Anything beyond 1 year, you are obsolete in the market.
Absolutely. Even I think it's lesser now with AI and stuff.
Exactly.
This is,
Exactly. With space robotics, not just robotics, I'm specifically talking about space robotics and space in general. You talk about 50-year timeline, like half a decade. No, not half a decade. It's half a century. So right now, NASA is planning missions that will be sent in 2050, missions that will reach their destination in 2050, 2060. That's the kind of timeline that you talk about when you talk about space, because it takes about a year to reach Mars in the first place, right? It takes more than a year to reach the farther planets like Jupiter and Uranus and Neptune, and Pluto not so much, because Pluto is not a planet anymore. But it's the scale at which things need to be planned is completely different. It's a rude awakening for someone who's coming from software background. It's like, all right, I want to build a space robot that will go to the moon. When are we launching? Oh, today is 2024. We're launching in 2030. I'm like, wait, what? And then you come back to the software domain. All right, we're building some product. When are we launching? Maybe 180 days, right? It's like complete shift. So, but then that shift is for a reason. Because I said, when you send things to space, you don't want it to fail. Whereas the software, if you get a blue screen, you restart the system, done, right? When you're in space, you don't have that luxury. You need it to work, or you need mechanisms that will help you, maneuver around in such scenarios. So that's what takes time. It is a very deliberate, it's a very intentional engineering process. It's a very rigorous engineering
So
process.
how do you keep going? How do you stay motivated in that kind of timeline?
You have to be sadist, and you have to be a little bit on the autistic spectrum, and you have to have ADHD, because you have a lot of things that you need to take care of.
Okay.
You need, when we were building MoonRanger, right? I was leading the avionics team, but I cannot build avionics in isolation. I have to talk to the software team. I have to talk to the power team. I have to talk to the mechanical team. I have to talk to the thermal team. So every team needs to know what the other team is doing, because this is as much modular system as it is. It's still a single integrated system.
Mm-hmm.
And when you talk about such integrated systems, you have to have a team which is working in that integrated manner. The engineering process, the rigor of the engineering process, every value is meticulously planned, calculated, fabricated, tested, refabricated, retested, and then put through rigorous tests such as vibration and shock, right? Because we think our cars running on potholes give us jerks. Imagine a rocket launching. Like, that's a whole different level of jerk. And then you take those kind of shocks and you say, all right, is this table going to survive? Absolutely not. You have to be very intentional. You have to be very rigorous with the way you planned, with the way you designed this table. So that's what it takes to build something at that scale. And then because there is so much work to be done, naturally the time taken will need to be more. I mean, we took about 40% of the time, or maybe 30% of the time, doing actual building. The rest of the time was either analysis or testing. 70% goes into analysis and testing completely. There's no two thoughts about it.
While we are at it, if you could tell us about what is the life cycle of the entire process of creating a spacecraft, just like where does it start, development, testing, and like how can one sort of see how that path looks like?
So NASA has really good resources on their website. Their systems engineering handbook is the Bible for any such process. And I think the world would be a much better place if everyone was following it, primarily because it adds a lot of emphasis on design, right? And it has clear milestones where you start with, all right, what do we want to do, right? It's like a requirements thing. So you have rigorous requirements that are put into place. Like, these are the objectives. I want to reach south pole of the moon to explore for signs of water and ice.
Mm-hmm.
Like, that's the objective. Mm-hmm. So then you take this objective and you turn it into requirements system. All right, what kind of a system will it take to achieve this objective, right? And then you have a rigorous requirements process. Then you have, because you have requirements, it needs review. So you have a requirements review process. So every step is basically create something, review it. Create something, review it. And all of this is very, very well documented on NASA websites. They have made it open source for everyone to watch, to read, to consume, to apply. And I think that's a really, NASA has fulfilled its mission of sharing with the community. And if I just give you a brief overview, it's like it starts from mission concept review. Like, this is the mission, what's the mission going to be? It starts from mission concept review, goes into preliminary design review, that goes into critical design review, and then it culminates into, I think, KDP, key decision points. And then the final review is the systems integration review, SIR. After SIR, it's the mission. Okay, so that's the life cycle of a space mission.
I had my first experience with robotics at Carnegie Mellon itself. So, we built this soft gripper with, silicon fingers and suction cups and tendons. And, every time we tried something won't work. And then I'm like, what didn't work? And it was challenging at times because, it was difficult to figure out what part of the entire circuit is not working.
Yep.
So tell us about a few technical challenges that you sort of came about in that entire journey of building space robotics, and then how did you sort of navigate that?
I call this phenomenon the excitation loop, right? Where
It's not at all exciting.
it's not at all exciting, where you start doing something, nothing works, so you're just down in the dumps. But because you have to deliver, you're like, let's keep trying. And then you have that, that dog meme, on fire, this is fine. You're in that state, like, all right, no, this is fine. Everything is
Suddenly, before the project demo,
and suddenly
something won't work.
Something won't work, and then it starts working. So you have, yes, it works.
The thing is that even when it works, you're not sure why it worked.
You're not sure why it worked. You're not sure why it didn't work.
Yes.
Fortunately enough, when you're working with space robotics, you have the systems engineering handbook at your disposal. So if you follow those steps religiously, that gives you a very good foundation to, how do you start debugging and where do you start debugging in the first place? Because you have everything documented. It's not like someone built a gripper and just left without telling you what they did, or someone built the electronics control board and left without telling you what they built. With the systems engineering handbook, every design detail is documented as much as possible.
So tell us about one instance where that came to your rescue.
I don't know if it was rescue or if it was a dumpster fire that came up. So in MoonRanger, I was leading the avionics team. I still remember that day vividly. It was about, I think, 5 in the evening when what we were trying to do is figure out the wiring, right? Because there were so many electronics components spread across the robot chassis. We wanted to make sure that the wiring was properly done and all the pin outs, let's say you have a power board which is bringing out 104 pins, and then you have an NVIDIA Jetson computer which needs 3 of them, and then you have another blah blah blah, right? So the electrical wiring needed to be sorted out. I had taken over the team at preliminary design review, okay, where supposedly the design was done. Okay, that's another story. So cut to 6 months down the line, we're like, all right, I think we have figured out most of the things. Let's just make sure that the wiring and the pinouts are correct. And I took that task personally because it needed to be done meticulously. And I was like, all right, I need to make sure that this is right. As I'm going through a spreadsheet, which is about 20 sheets, and each sheet has about 150 to 100 rows describing the pinouts and where it is going, I discovered that everything that we have done so far, there is no power output coming from the power management system. Okay, so what that essentially means is you have the avionics, but it's not going to receive any power because you have not accounted for power anywhere. All right, that's not a big deal. We just need a couple of pins to go around. Guess what? We don't have any real estate on the PCB to bring out those pins. All right, let's introduce a PCB. No, there's no mechanical volume left where you can introduce a PCB anymore. All right, let's figure out if there's a if we can squeeze on existing PCBs. No, all existing PCBs are full. There's nothing you can do here. That was when all of us started stressing out. Now, given that I had some experience leading teams, I was like, this is, and pardon my French here, this is a clusterfuck. We need to untangle this mess. Let's take a step back, stop doing everything we're doing right now, and go get beer. We're not going to work tonight. We're just going to get drunk because this is not something which we can fathom. Keep in mind, we are supposed to deliver the rover 3 months from now. So if 3 months from now, if we are supposed to deliver the rover, you cannot have a situation where your wiring is not done. So then we chilled that evening, got drunk, ranted, complained, and like, all right, we have had our emotional outburst now. Next day, we are back at work at 9 a.m. Sat down with the mechanical team. All right, what can we do? Came up with a solution of completely rearranging the avionics part. And within a week, we had everything sorted out. So that was, I think, that specific incident, I think it's a core memory from building space robots. And because there is so much detail to be taken care of, it's very easy to miss. And I think that was a lesson learned.
I think the beer
Lesson
did the
learned.
magic. It's more than anything
Beer did the
from what
magic.
it sounds.
Alcohol has been the solution a lot of times. But no, it's basically making sure that you're not carrying any distress while you're working, right?
Absolutely, yeah.
And if you're mentally ready to take on the challenges become easier. Whereas if you're stressed, every challenge is 100 times bigger than it really is.
I'm really curious about how access to capital works in the space robotics industry, because you're not getting an ROI for 50 years. So like, what are the sources of capital, and like even the missions that you have been part of, how were they funded?
There's been a big shift in terms of capital. So far, only the government was spending, and it was managing the missions end to end. And so the capital was primarily the government. Now, fortunately for us, the government decided, all right, our business is to manage the money, not the tech. Let the people who do the tech best manage the tech. So NASA started this initiative of privatization of space, right? And so that's how it said, all right, we want to send this mission, but you guys do the work, right? That's where the journey started. And because of government's interest in this entire privatization space, VCs turned their heads towards space, thinking that we can invest and we can get multi times return on our investment. What's been happening since then is there's a lot of capital that has been infused in the system, but because this is a completely new economy that's coming up, I see that the returns will be slightly delayed. Now, a lot of VCs are not necessarily familiar with that whole process. There are a few VCs which are brilliant, who have people who have worked in space missions running the VC, and so they understand the whole cycle. They understand the whole process. Whereas people who have traditionally invested in SaaS products, who have traditionally invested in consumer, B2C kind of products, they don't necessarily understand the whole game, and neither do they invest smartly in this industry. So as a space robotics, as a company that builds space robots, we have to be really careful on who we approach for money. So far, Element Robotics is funded through government grants, primarily Australian government grant. We were part of the ELO2 consortium for building the design of the Moon Rover, and as of December last year, our consortium won the second stage of the grant, which is to actually build the rover and send it to the moon, right? So our design works in some sense. So far it's government funding in some way, shape or form. And some smart VCs who know how the system works and they are investing in it. And then obviously you have the high net worth individuals who have a passion for space, who have a very exploration mindset, or who have always wanted to go to space but did not really have an outlet for it so far. And now they have an outlet of a budding or of a upcoming space industry, which is commercial, which is privatized, and it is not in the strongholds of the governments of the world. So they are also investing very heavily. But obviously, as with all things fundraising, this is a challenging task and something that we are about to embark upon.
So tell us about Element Robotics. I mean, it's been a while we've been chatting, but our audience must be curious about Element Robotics and what it does, what are the kind of things that it builds, and specifically its participation in the ELO2 consortium as well as the Moon to Mars Trailblazer mission. So just tell us about it, and how is it going so far?
So our journey has been pretty fun, I must say. We started off in 2022, where so my co-founder was leading the software team, I was leading the avionics team, and both of us were sitting, chatting. This is good stuff. We want to continue building it after Carnegie Mellon. How do we do this? What do we do? So we approached our professor. We're like, you keep getting these contracts. Why not hire us as consultants for your projects? So he was like, you fools don't even have a company. How do you expect me to hire you as a consultant? Like, all right, hold my beer. Let me incorporate. So that's when this whole process started. We're like, all right, we're building space robots. Our company's name is something. We'll figure it out. With this idea, we went to Houston. There was a space conference happening. And when we landed there, we were like, we got to know that there's some business pitch competition happening. We're like, well, why not? So we sat the night with a wine bottle each, started making the presentation, started building a website. And within a couple of hours, we had everything ready. The next morning, we pitched. We won the business pitch competition. And that's what sort of instilled a faith in us, saying that, yes, the idea that we have of building a space qualified robot platform has some merit in it.
Right.
Even if two people believe in it, there is something there, right? And it's worth picking on. So we did that. We won the competition. With that money, we hosted the website. We incorporated
the fun part,
the business legal mumbo jumbo thing. So we incorporated 3 independent entities in India, Australia, and the US. India because I'm Indian, Australia because my co-founder is Australian, US because we were sitting in the US. And we made a LinkedIn page, etc. So we started sending out these vibes that we are in business, we want to work. And we got an inquiry from Australia. We got approached by a professor who was part of the ELO2 consortium, and Australian government had floated this request for proposals for building Australia's first lunar mission. So it was a huge opportunity. So he was like, oh, we're forming this consortium. Do you guys want to, the capabilities that you have, we don't have in the consortium so far. Do you guys want to join us? We're like, obviously, yes, we are looking for business. So 2022, February, we put in the contract with the consortium. But as with all things government, the results,
forever.
It takes forever. The results were supposed to come out in May of 2022. And I had full plans of abandoning my master's in Carnegie Mellon and going to Australia to work.
Good that they're late.
They're late.
At least you got to the commencement.
Yeah. I can boast about having 4 degrees now. So that got delayed, but we kept chugging along. We kept putting in for grants. We kept applying for grants and all. January of 2023 is when the results came out. They were publicly announced in March, and we were in business, basically. And from then onwards, I landed in Australia. My co-founder was already in Australia. We started on the Trailblazer stage 1 that we had got. That got delivered in July of 24. The design, basically, for preliminary design review. That's the milestone. And the results for stage 2 were supposed to be announced in October. They didn't. So I came back to India. I was like, I don't want to burn my company's cash. So I came back to India, and the results were announced in December. Our consortium had won. Mm-hmm. So now we are in the process of, the prime contractors are in the process of contracting with the space agency for the stage 2. And we'll get to know what we are building, how we are building, how much we are building as a consortium member. sometime in the next couple of months. So that's been the journey so far.
A very different journey from,
A very
the
different journey. Yeah.
others we have heard so far.
Yeah.
for sure.
And in the meanwhile, we also had put in for another grant, and we won that grant in November last year. So right now we are sitting on 2 different grants, and we are marching ahead. And because we have this traction, because we are now finally getting to a point where our product will be viable and feasible to commercialize, we are also going out in the market looking for investors now, because we are at a stage where the risk has been mitigated. We have capital, we have money to build the product out. Now we need investors to scale the product to go to the market.
So, for budding entrepreneurs who want to get into space robotics, how would you recommend them starting off? Like, should they start with, just sort of collaborating with a research university who is specializing in that area so they develop that capability? Or, connecting with the space agencies or being part of the consortium, because I'm sure that also requires certain expertise. So it's a vicious circle. And how would you suggest they get started?
So I have a slightly unconventional take on it. And I'm going to be using profanity when I describe it. But my approach to anything and everything in life is very simple. Fuck around and find out. Right? What that essentially means is, if you want to do something, just take action. That action could be as simple as looking at the data sets that NASA releases, analyzing it, and putting it on a website saying, hey, this is my analysis. Making a blog post out of it. That's the simplest unit of work you as an individual can take up. Mm-hmm. How did I land in this whole industry, right? Yeah. I had no robotics experience. I hadn't touched electronics for a decade. And all of a sudden, I was leading the avionics team. Why did that happen? That happened because it seemed interesting. It piqued my curiosity. So I followed my curiosity. And because I followed my curiosity, I went the extra mile to do things that ordinarily I wouldn't have done. Right? So because I was interested in it genuinely, I kept, plucking at it. I kept hammering at it. And because of this, I caught the eye of my professor, who was like, we need someone who can lead the team, because we don't have any leadership experience. And because this was a student sort of team, we want someone who can lead the team. I was like, it'll look good on my resume. Like, very small, you bring down the downside in your head, because the only thing that will ever limit you is your own negative self-talk. The moment you put that aside, what's the worst that can happen? Will you die? No, go for it. As simple as that. So I took the charge of the team, and the day I take charge, I'm told, guess what? We have a critical design review coming up in a month and a half, and you are presenting. I'm like, I'm sorry, what? What just happened with me? So he's like,
you asked for it.
Exactly. So then he's like, it's okay if you cannot deliver, we'll have someone else do this. Now that I took personally, I was like, excuse me, what? I'm leading the team. I'll take ownership.
Right.
I'll take ownership. I'll take the charge. So I will do that. And when I looked at the actual documents, there was much left to be desired in the design that was there. Mm. So between PDR, the preliminary design review, and CDR, the critical design review, not a whole lot of progress had been made in terms of solidifying the design. Mm-hmm. So we basically, get down in the trenches, heads down, hands on, start working 14, 16 hours a day. You churn the whole design out, you validate that between the teams, figure things out, and deliver. Delivered well, got special compliments from the NASA people saying, yeah, avionics presentation was really good, and blah, blah, blah. That was a good ego boost. So wrapping this back to the original question, action, curiosity, negative self-talk, keeping away the negative self-talk. These are the only 3 things which can help you grow in any kind of field you want. It's not just space robotics. honestly, space robotics sounds very, oh my God, what is that? But when you actually get down in the trenches, it's all, you have to apply your brain, you have to read, apply that knowledge, and figure things out, as with all things in life, right? It's just that the rigor is slightly higher. So you need to be up for it. That's the only advice I would ever give.
So as you mentioned earlier, earlier the funding came only through the government, and now there's more privatization that's sort of coming into the entire space industry. So specifically when we talk about the Indian government, there have been initiatives. They had a 2% sort of a global market share when it comes to them being on the map in terms of space technology, which they definitely want to grow upon. And they've kept aside $119 million of VC fund for softwares that are in the space area. What is your perspective on this, and how do you think space startups can specifically benefit from these kind of initiatives?
So,
Is it enough?
I mean, if you talk about setting up a whole new economy, maybe there's more required to, take it over the, what do you call the catalyst, the energy of excitation in chemistry. You have that energy of excitation where after which the things become self-sustaining. I think there's definitely more required there. Specifically in the Indian space industry, because we have a whole lot more problems in terms of regular social life in our country, we are currently focusing on how does space industry bring things back to Earth, right? What that essentially means is we are investing in space for Earth economy, not space for space economy, right? Now, the key difference there is space for Earth economy requires immediate return of investment. If you think about it in those terms, where you're launching satellites, those satellites have immediate business, which could either be telecom, it could be remote sensing, it could be n number of use cases which are bringing space, the benefit of space back to Earth. What India has not been investing a lot, apart from maybe the Gaganyaan project, is doing space for space. Like we had the Mars Mangalyaan. We had the Mangalyaan go, which was in a very limited budget. Great, because we are frugal by nature. So not a lot of investment is going into space for space. Simply exploring what's there on the moon, simply exploring if we have minerals that we can bring back, right? And there's a reason for it. Because if you look at the West, if you look at the US, if you look at, in fact, our neighbor China, they've all figured out the launch technology, which is reusable now. India is maybe a decade behind that, right? We have private space players doing that. Then there's no commercial use case for how do you return the investment. So if I'm sending a rover to the moon, whose sole job is to explore and map the surface, how do I make a case for saying, all right, I have this map of the moon, pay me money for it, right? So those kind of use cases, which are exploration for the sake of exploration, those use cases are still very limited in terms of getting funded by the Indian government and even by the Indian VCs, which are investing in the aerospace defense sector. The good thing is that this technology, this entire emerging economy area has taken up a lot of media bandwidth, and so people are now excited about it. Now, as with anything, humans are the ones who will always solve the problems. So in that sense, we are on the correct path. It will take a little more effort to get us to the station or the goal. So we have started that journey. I think if any Indian startups are looking to start in this area, easiest journey would be to go into satellite area. You have startups like GalaxEye in Australia. You have startups like Digantara. You have there's one more startup that I cannot figure out.
Pixel?
Seem to know. Pixel, yes, Pixel has done a phenomenal job in raising money. So it's the money is there. It's being invested, but if you look at the actual numbers, Pixel raised a lot of money, whereas the other startups are still very low in the money that they've been able to get from the market, right? So we have success stories, but they are far and few in between. Whereas if you look at the US ecosystem, you have this whole entire Eclipse group of companies, which is commercial lunar payload services providers, right? You have a whole bunch of companies which are doing all of these things. And some of them have actually started succeeding. Like you have Intuitive Machines, which actually landed a lander on the moon last year, which is a feat only our Indian Space Agency has been able to achieve so far. So there's a stark difference in the amount of funding and the kind of work that is being done, but we are on the right path, is what we can say right now.
So, as we talk about sustainable practices all over the globe in different industries, when we talk about the space industries, there's a lot of orbital congestion.
Yeah.
And so, what is your perspective on how we can have more sustainable practices when it comes to space robotics?
It's a very tough line to toe, actually, because if you want to make something sustainable, you have to put in some frameworks and guidelines and rules in place. But then those rules and guidelines can hamper innovation, right? So then it's a very precarious balancing act that needs to happen, where you're following some guidelines, but you're also free to innovate. You're free to put things in orbit, but you're also mindful of how many launches you're doing in a given year, or what kind of orbits are you targeting, so that so LEO, which is low Earth orbit, that is really popular these days because it has a natural tendency to sort of deorbit after a certain period of time and fall back and burn in the atmosphere. So that's the perfect place to experiment. But then, because it's the perfect place to experiment, it has become crowded again. So, as companies, there's no real good answer here. Like, what is the sustainable best way? I think because it's a completely new and emerging area where people are everyone is getting involved. It'll take some time to figure out what the best practice is, as with anything new. So, for example, when oil and gas exploration started, it was a mad rush. Anyone could do anything, similar to gold rush, right? It was anyone can dig anywhere and blah, blah, blah. And then when people started seeing that, all right, this is not sustainable, this guidelines and rules started coming up, and companies and everything sort of started getting organized. And what we see today is a very organized sector. Same thing will happen with space. Right now, it's a mad rush, and things will sort of start falling into place gradually.
One NASA mission you wished you would be part of, which one would it be?
Sending humans to Mars.
बचपन का कोई ऐसा मोमेंट जिसमें specifically related to space that you remember? Astronomy.
I think, spotting constellations for the first time. That was like, oh my God, there are shapes in the sky.
कोई भी everyday work that you want a robot to take care for you?
Washing the dishes. I hate that.
Have you ever thought कैसे बन सकता है ऐसा robot?
हाँ, easy है.
अच्छा.
रोबोट आर्म चाहिए,
हाँ.
और डिश वॉशर चाहिए, एंड एक मोबिलिटी प्लेटफॉर्म चाहिए. मोबिलिटी प्लेटफॉर्म का काम होगा किचन में इधर उधर जाना. रोबोट आर्म का काम होगा कि grip the dish in an appropriate way and load it in the dishwasher. बंद करके go for it.
So budding entrepreneurs, you have an idea. We have an investor who would be very keen to invest.
Yes. If not invest, certainly advise. I'm yet to earn my own.
If you could recommend certain movies which are more like related to space or sci-fi that you really looked up to while growing up.
While growing up, not necessarily, क्योंकि माता जी ने केबल कटवा दिया था घर पे, तो कुछ देख नहीं पाते थे. I think in recent times there are some TV shows which I really love. One is The Expanse. That talks about intergalactic travel and everything. It's really well made, so I would highly recommend watching that. Then there is a TV show called The 100, The 100. That talks about a future of humanity in semi-dystopian, semi-utopian kind of setting, and it talks a lot about human nature, right? So, irrespective of where humans live, it talks about we have that animal instinct of food, water, and territory, right? Those kind of needs, and how can things play out in a future where people are traveling in this space, and so it's a very interesting show to watch. I think those are the two I would recommend watching. Very interesting. I found them really interesting.
And how about some book recommendations for our audience?
Oh, the Case for Space. Okay. It's a very well written book, and it shows a future. It envisions a future where space travel will be a commonplace. It envisions a future where humans will travel to space as easily and frequently as they travel to another country. So I think that's a really good book to read.
What are some of the tools and softwares and applications that you like to use in your day-to-day life to make your life simple as an entrepreneur, as a leader?
Miro, M-I-R-O, Miro. That's my go-to tool for any kind of planning and just visualizing my life. Every time I'm feeling overwhelmed, I sit down and make a mind map and see where all my life is spread. So that's really helpful. Trello for personal task management, and Google Calendar, phenomenal. I don't have to remember anything. Everything is driven. My life is driven by Google Calendar. Yeah, I think, and I mean, maintaining my own journal kind of thing. People often use Notion for it. I am happy with my Google Keep Notes and Google Docs, where I have a document called Life, where I just putting things down every time I have an epiphany or have something which I want to record for future reference.
No, I think that's a great recommendation. Usually, when specifically somebody is working on ideas, and they're sort of farming up for ideas, they just come in bits and pieces while you're in the middle of a conversation or something. So it's good to sort of take note of them for future reference, because when you get down to it, you're like,
what was I thinking?
I did have a lot of ideas, but what were they?
Exactly.
Yeah. So we have come to the end for our podcast for today. It was super interesting to know about the space, which is beyond what we can see in front of us on Earth. And so see you next time. Until then, keep dreaming about reaching the stars. And if you want to reach them, you can take few steps to do that as well. So see you then.